Good morning, sir. I am Sirisha from Tribly Department. Today, my topic is Maxwell equations with one example. Maxwell second equation. Maxwell second equation divergence dot b bar is equals to 0. The magnetic flux lines established by an unspecified current and closed surface without originating point and determination point. That means the closed surface integration of magnetic flux is 0, as explained below. The flux passing through the closed surface S is given by flux is equals to closed integral closed surface b bar dot ds bar is equals to 0. That implies equation 1, Gauss law for the magnetic field. Using the divergence theorem, the equation 1 can be written as phi is equals to closed integral closed surface b bar dot ds bar is equals to integral volume divergence into b bar into dv is equals to 0. That implies equation 2. In equation 2, since the above enclosed by the closed surface is not 0, the divergence dot b bar should be 0. We satisfied the equation. Therefore, divergence dot b bar is equals to 0. This is equation 3, Maxwell's second equation. The Maxwell second equation signifies that the magnetic field is solenoid in the nature. Next, Maxwell third equation. Divergence into h bar is equals to j bar. Consider a differential rectangular surface in a magnetic field established by an unspecified current as shown in the figure. Let H naught is equal to field intensity at a point P. H naught is equals to Hx Ax bar plus Hy Ay bar plus Hz Az bar. Then the closed path integration of the H bar over the path 1 minus 2 minus 3 minus 4 minus 1 is given by integration closed surface L H bar into dl bar. That implies integral 1 to 2 h bar dot dl bar plus integral 2 to 3 h bar dot dl bar plus integral 3 to 4 hx dot dl plus integral 4 to 1 h bar dot dl bar. That is equation 1, where integral 1 to 2 h bar dot dl bar is equals to hy plus rate of change of hy with respect to x dot, where integral 1 to 2 h bar dot dl bar is equals to hy plus rate of change of hy with respect to x into delta x by 2 into delta y. Integral 1 to 2 h bar dot dl bar is equals to hy plus dou hy plus dou x dot delta x by 2 into delta y. That implies equation 2. Integral 2 to 3 h bar dot dl bar is equals to hx plus dou hxy plus dou y dot delta y by 2 into minus delta x. That implies equation 3. Integral 3 to 4 h bar dot dl bar is equals to hy minus dou hy by dou x into delta x by 2 into minus delta y. That implies equation 4. Integral 4 to 1 h bar dot dl bar is equals to hx minus dou hxy by dou y into delta y by 2 into delta x. That implies equation 1. Closed surface L is equal closed surface integral closed volume h bar dot dl bar is equals to dou hy by dou x into delta x into delta y minus dou hy by dou y is equal dou y delta x into delta y. Similarly, dou hy by dou x minus dou hx by dou y ds. Limits dx is equals to 0. Integral volume L h bar is h bar dot dl by s is equals to dou hy by dou x minus dou hx by dou y is equals to Jn. Divergence into h bar is equals to Jn bar. That implies equation 6. The above equation 6 is known as Maxwell's third equation or point form of Ampere and Circuit's law. Next one example of Maxwell equation. Find the value of k in the following pairs of the field in the free space such that they satisfy Maxwell equation D is equals to 5x 5x ax minus 2y ay minus kz az is equal az into meter per second square and b is equals to ay mt. Solve the problem given. We can apply the Gauss law for the electrical displacement. D is equals to 5x axy 5x ax minus 2y ay plus kz az is equals to meter per meter square. Divergence dot D is equals to 0. Divergence D is equals to dou by dou x f of x plus dou y into minus 2y plus dou y dou z into kz. Dou by dou x into 5x is equals to 5. Dou by dou x into minus 2y is equals to minus 2. Dou by dou z into kz is equals to k. Divergence of D dot divergence of divergence dot D is equals to 5 minus 2 plus k is equals to 0. That implies k is equals to minus 3. Thank you, sir.